Okay, here we have that is Dalton atomic theory. Okay, so we have discussed in the previous class the law of constant proportions and law of conservation of mass. Today we're going to discuss the Dalton atomic theory. So let's one more time we shall give you some questions here. For example, if you have the ratio of carbon dioxide when react with oxygen, it gives you CO2. Okay, so if you have you have 80 grams, okay, let you have 4 grams 4 grams of oxygen, then how many grams of carbon will be required to completely react with 4 grams of oxygen, and how much grams of CO2 will be formed? Tell me. Tell me. So first of all, you will write the ratio, combining ratio of these two. So if you have
Yes,
this
sir.
carbon, so what is the ratio of carbon and oxygen, combining ratio?
3:8.
3:8. Everybody turn on your camera. There, turn on your camera. Okay. So 3:8 is the ratio. Yes, very good. 3:8 is the ratio. So if we have this 4 grams, then how many grams of oxygen will be required? Carbon will be required.
Carbon will be 1.5.
Yes, it will be 1.5 because we are just halving this one to get 4. So you have to halve this one. Okay, got it? Arya, you got it?
Yes, sir.
So it will be 1.5 or 3/2 grams. Okay. And first of all, 3 plus 2, you will get 8. 8 grams you are getting. Sorry, 11 grams you are getting here. Now you will get how much? 3/2 plus 4, you will get 1.5. You will get half of this. Okay. So it will be 5.5 grams. Okay. Grams of carbon dioxide will be formed. Okay. Got it?
Yes, sir. Yes, sir.
Okay. Next is Dalton atomic theory. Dalton atomic theory. Noted? That noted?
Yes, sir.
Yes, sir.
Now moving towards the Dalton atomic theory. So Dalton gives this theory. Okay. Dalton gives this theory, and he proposed this theory by giving some points. We call them postulate. Okay. Based on upon the law of conservation, laws of chemical combination, Dalton atomic theory provided the explanation for the law of conservation of mass and law of constant proportion. He gave the following postulates. The first postulate of the Dalton atomic theory, this is the Dalton atomic theory. The first postulate of Dalton atomic theory is that all matter is made up of tiny particles. We call it atoms. Okay. So all matters are made up of tiny particles. We call them atoms. Very good. And atoms are indivisible particle of matter. Means atoms can neither be created nor destroyed during a chemical reaction. These are indivisible. Actually, we can further divide the atoms into subatomic particles like electron, proton, and neutron. But this we will say that here that is actually we are just dividing them in the not in the chemical reaction. There are two types of reactions take place. One is the one type of reaction is the reactions in which the atoms is broken, and that type of reactions is called nuclear reactions. And another type of reaction is the reaction in which the bond between two atoms are broken. Okay, like for example, let me explain you here. Okay, Like for example, if you have two hydrogen atoms, one hydrogen atom is this one, and it is bonded with another hydrogen atoms, and it is H2. Okay, this is another hydrogen atom, and it is bonded with another hydrogen atom. This is the two oxygen atoms, and it is bonded with another oxygen atoms. So if you are just breaking their bonds, and you are arranging this, the two hydrogen atoms, they are combining with one oxygen atoms. Two hydrogen atoms, they are combining with one oxygen atoms. So if they are combining, they will form water molecule H2O. So we just break the bond between two atoms, and we are just rearranging them. Actually, we are just rearranging them. Okay, the two oxygen atoms, one oxygen atom will goes to this one oxygen atom will goes to this one, and they will form. Now there will be no bond between hydrogen and hydrogen. There will be bond between one hydrogen and one oxygen, one hydrogen and oxygen. So we are just arranging them. Rearrangements of atoms are taking place. Actual atoms is not broken. But in nuclear reactions, we just break the atoms into their subatomic particles. They break the atoms actually, and the energy is being released. So that type of reaction is called nuclear reactions. So in nuclear reactions, atoms are broken, but in chemical reaction, this is the chemical reaction. Atoms are not broken, the bonds are broken. Okay. So Dalton atomic theory is based on the chemical reactions. It is talking about the chemical reactions. The laws of chemical reactions are not, chemical change are not applicable for the nuclear reactions. Okay. For example, we say that atoms can neither be created nor destroyed during a chemical reactions. So it is for the chemical reaction, but atoms can be destroyed in a nuclear reactions. Got it? Got it? We
Yes,
say
sir.
that mass can neither be created nor destroyed, but mass can be destroyed in nuclear reactions. We convert mass into energy in nuclear reactions. Got it? So this, what we are studying here is, this is applicable for nuclear reactions, not for chemical. Sorry, this is applicable for chemical reaction only, not for the nuclear reactions. So Dalton atomic theory is about the. So here atoms are indivisible particles which can't be created or destroyed during a chemical reactions. And this proves law of conservation of mass. For example, if we have hydrogen gas and react with oxygen gas, it will form water. So where is what? There are two oxygen atoms. Where is one oxygen atom? The mass of two hydrogen atom is 2. The mass of two oxygen atoms is, because O atom does not
32.
exist. O2 oxygen atom exists in the form of O2. So if it is reacting, it will give you one oxygen atom is 16, the two oxygen atom is 32. And what is the mass of one water molecule? 2 plus 16 will get 18. So here the total mass is
18.
34. Two oxygen atoms, sorry, 32. Two oxygen atom is 32. So it is 34, but here is 18 only. So mass is destroyed here, but it is not so. It is not so. We have to balance this one. This will learn in the higher classes. To balance the chemical reaction, that we will have 4 hydrogen atoms should be here, and oxygen atom should be 32, and there should be 2. Okay, so mass can neither be created. That will learn in the higher classes. So this gave that mass can neither be created nor destroyed during a chemical reaction, and this proves the law of conservation of mass. So this will be asked in the examination. Which postulate of Dalton atomic theory support the law of conservation of mass? So which postulate support? That atoms can neither be created nor destroyed during a chemical reactions, and you have to mention here that in the chemical reaction we are talking about. Okay, otherwise mass can be destroyed in a nuclear reactions. Okay, the third postulate is, let me explain you, then you have to write. Atoms of an elements are identical in mass. So atoms of an elements are identical in mass and chemical properties. Okay, atoms in an elements are identical in mass. So this was a drawback. We'll discuss this one, that this statement is true that atoms of identical elements have same chemical properties, but they don't have identical mass. This is a drawback. We'll learn this one, that why this statement, that they identical atoms have same mass. So it is not so. Different atoms can have also same mass. For example, argon is going to have mass 40 and calcium is also going to have mass 40. They are different atoms. They have same mass but different chemical bond. So it is not so. We'll learn this one, that what are these. So identical atoms of and elements have identical mass and chemical properties. Okay, and atoms of different elements have different mass and and different chemical properties. So in this two postulate, there is error. We will write it, but first of all, we have to write it exact what he said. Okay, that the same atoms should have same mass. Okay, what he said, and same chemical property. The same atom should have same chemical properties. It is correct. It is correct that, for example, let me explain you that. For example, if we are having the mass of carbon, there are the two types of carbon atoms we found in nature. Okay, one is which is going to have mass 12, another which is going to have mass 14. And why they are having two mass difference? We'll learn this one in the structure of atom chapter in the next chapter. Okay, but there are the two types of atoms of carbons are present. One is having the 12 mass, another is going to have 14 mass. Okay, so but they have the same chemical properties. Their atomic number is 6. They are having the same chemical properties. Okay, they are having the same chemical property but different mass. So atoms is element is same. Both are carbon, same element, but different mass is possible. So at identical elements, the same elements can have different mass. And what he said that they must have the same mass. So it is incorrect. But they identical elements should have the same chemical property. This statement is correct. So half of the statement is incorrect and half is this correct. That they have the same chemical properties. Identical element should have the same chemical properties. It is correct. Identical element should have the same chemical properties. It is correct. Got it? Got
Yes.
it? But if I talk about that, they must have the same mass. No, it is not. Identical elements can have different mass. Okay. Now, what he said in the next line, he said the atoms of different elements should have different mass. It is must. Most of the time, it has happened that different elements should have different mass, but this different element can also have same mass. Yes, it is possibility that, for example, nitrogen has 14 mass. And carbon atom which is going to have 14 is also having 14 mass. One type of carbon is also going to have 14. So both are going to have 14 mass. Similarly, argon is same 40 and calcium is also going to have 40. So both are argon is different from calcium. Argon is a gas and calcium is a metal. Okay, but both are going to have same mass. So different element can have same mass. And he added that different elements should have same mass, but here are different. Sorry, different elements should have different mass, but here it is same. Okay, and he added further that if the elements are different, they must have different chemical properties. Yes, it is correct. So about the mass, he was not correct, but about the chemical properties, he was correct. That different elements should have different chemical properties, and same element should have same chemical properties. It is correct. But what he said that different elements should have different mass, it is not correct. And what he said, same element should have same mass, same element should have same mass, it is also not correct. Same element can have different mass, and different element can also have same mass, it is possible. Okay? Got
So
it?
did we mention that while writing or do we not? So while writing the postulates, do we write those 2 points or do we not?
We need to write those. We need to write those ones.
Even if they're incorrect?
Yes, if it is incorrect.
Okay.
We will write it, we will learn it in the drawbacks. That what are the drawbacks of data dynamic theory? We will learn it, okay?
Okay.
Got it. Next is yes, Rima. No, not good evening. I'm not talking to you because you are just late for 20 minutes. It is more than half an class. Okay, so that is not fine. Today you prove me that you are not a good student, Alvina and Rima both, because you have joined approximately 20 minutes late. It is not fine.
Sorry,
Sir,
the message wasn't there in the group, yeah.
What are you saying?
The link was not there in the group, sir.
The same link was given every day. Was it informed? Were you informed?
No, sir, I wasn't informed that today there was class.
When you get the link?
Now only I got the link. Now you sent it.
Yeah, I will talk to the technical team. I will talk it. Okay. So I'm sorry for that because it's our mistake. We are very sorry. But I think that you both are not sincere. That's why I just scold over you. So let it be. And you both please turn on your camera because focus modes are on and turn on your camera. So Alvina and Rima, we are just studying the postulate of data driven theory. Then we're going to proceed further. Okay. So we are just revising this one. So keep in mind here. Okay. Rima, you also. And these are the new students that join your batch. Nabila, Zaid, and Ira. So they will be going to.
Sir Arya.
Sorry, Arya. Arya. Okay. It is very simple. R means R, this alphabet R and Ya. It's simple. I am getting confused with Ira. No, it is Arya. Yes, I will remember it. Okay, Alvina, turn on your camera and Rima, you also.
Yes, sir, I'm on it.
So, what does he say? First of all, that all matter is made up of very tiny particles called atoms, and atoms are individual particles which can't be created and destroyed in chemical reaction that we have studied. Okay, and this is incorrect one. This statement is incorrect one. Do you know that why Alvina and Rima? That why that this postulate is incorrect? That atoms of identical elements have identical mass. Why? Atoms of identical elements have identical mass. Why this statement is incorrect? Rima and Alvina, can you tell me? These two postulates are incorrect. Half is incorrect. This portion is correct. About the chemical properties, it is correct. But have different mass, this is incorrect. Next, what he told that atoms combine in a ratio of whole number. Atoms combine in a ratio of whole number to form compound. Atoms combine in a ratio of whole number to form compounds. Okay, got it? Whole number to form compounds. This is very important, and this law proves the law of constant proportion that atoms combine in a whole number to form. For example, two hydrogen atoms and one oxygen atom combine together to form H2. One carbon and two oxygen atom combine to form CO2. One nitrogen atoms and three hydrogen atoms combine to form NH3 ammonia. So their ratio should be same. You cannot have that. You cannot say that in London we are going to have water formula as H4O5. No, it will be same. It is H2. Okay. So the ratio of combining of hydrogen to oxygen is 2:1. Okay. And the relative kinds and numbers in atoms are constant in a given compound. The relative kinds mean the type of atoms and are constant. For example, if I'm having two hydrogen atoms and one oxygen atoms, it is constant in water. Every water molecule should have two hydrogen atoms and one oxygen atom. Rima, are you there? Why are you not turning your camera? Are you fine?
No, sir. Today I'm feeling more sick, sir. It's not like yesterday.
Okay, so you are on your bed and you are having your mobile phone over like this, and you are just lying on your bed.
No, I'm writing its every
You are
answer.
right. So please. Alvina, have you noted the Dalton-Nevitt theory postulate in your copy?
Yes, sir.
Do we have noted this portion? Do you have this Dalton-Nevitt theory postulate in your copy?
No, sir.
No?
I don't think so. You explained the law of conservation of mass.
Oh wow, we are on the same portion. Okay, let it be. So please, dear students, please note it down. The postulate of Dalton-Nevitt theory. These six postulates, note it down.
Okay.
Talk to the technical team why they have sent you the link so late. It's not fine.
Sir, even I thought there is no class today because there was no any link.
Okay, beta. So I have talked to him, to the technical team, and he said that we were sending the link to the so many students. So it was not received actually due to some issue in WhatsApp or something. So Rima and Alvina,
Okay, sir.
it's okay. Okay. Done?
Sir, 1 minute.
Okay.
Yes, sir, I'm good.
Done? Okay.
Yes, sir.
Alvina done? Nabila?
Done, sir.
Arya?
Yes, sir.
And Zed, you? Where have you gone, Zed?
Done, sir.
Okay. So the drawback, more clearly, the drawback of this question. What is being asked in the examination? That which postulate in dynamic theory support the law of conservation of mass? So this postulate supports that atoms are indivisible, okay, which can't be created and not destroyed including a chemical reaction. This postulate support the law of conservation of mass. And second, which postulates support the law of constant proportion? That is, atoms combine in a ratio of whole number to form compound. So this law supports. So okay, and what is being asked in the examination is the drawbacks of dynamic theory. So let's study the drawbacks of dynamic theory. Okay, drawbacks of dynamic theory. More clearly, the drawbacks we will study, and this will be clear more when you will learn the fourth chapter, and in that chapter you will learn the atomic number and atomic mass. Okay, the number of neutron and proton, electrons. So that you will going to study in the next chapter. But I'm going to write here first because we are just here on the topic. Drawbacks of dynamic theory, but more clear, this thing will be cleared when you are going to when you will learn that chapter, when you will learn what is electron, what is proton, and what are neutrons, what is atomic number, that you will learn in the next chapter. Okay. So drawback is that turn on your camera. Drawbacks. So first drawback was that he said that atoms are indivisible, but atoms can be what he said about the chemical reaction, but some of the teacher used to write that he said that atoms are indivisible, but atoms can be further broken into subatomic particles like electron, proton, and neutron. But it does not, I'm just reminding you, during a chemical reaction, it does not break. It break in a nuclear reactions. It break in a nuclear reactions. Got it? So we will write it as a possibility because some of the teacher used to say that atoms are indivisible. He said that atoms are indivisible, but atoms can be further broken. But it can be broken in chemical reactions. Law of conservation of mass is also not applicable for uh, the nuclear reaction. It is applicable for chemical reactions. Okay. So if some teacher says, so I'm just writing here. Otherwise, this postulate is already correct. That atoms are indivisible and they can be further broken. Okay. Now, okay. And the next one, next. So atoms are indivisible, divisible. Atoms are, Zed, are you there in the class? Atoms are indivisible during a chemical reaction, chemical reactions. Yes, it is correct. But they can be broken into subatomic particles, into subatomic particles, which is electron, proton, and neutron in a nuclear reaction. Nuclear reactions. Second drawback was atoms of same element, similar elements can have different masses. For example, nitrogen 14 and carbon 14. Sorry, atoms of similar element can have different masses like carbon 12 and carbon 14. Like hydrogen 1, hydrogen 2, and hydrogen 3. There are three types of hydrogen found. One hydrogen with mass 1, two hydrogen with mass 2, and the third one is hydrogen with mass 3. So there can be three types of. And this type of atom that are going to have the same mass, so different masses but same element, they are called isotopes. So in case of isotopes, what we call them? It's same carbon, okay, but different mass. So we call them isotopes. What we call them? Isotopes. Okay. So we'll write here that atoms of different elements can have different masses in similar element can have different masses in case of isotopes. But he said that similar elements, atoms of similar element should have same mass. Okay. Done?
Yes, so like if they have different mass, they are called isotopes, right?
Yes.
Okay.
Same elements, but different masses are there. They are called isotopes. We'll write the definition of isotope later. After this one. Okay. Got it? Rina, done? Done?
Yes, sir.
And you, Nabila, done? Zaid, Rima?
Done, sir.
Sir, 1 minute.
You're writing?
Yes, sir.
Okay. Have you taken the medicine?
Yes, sir.
Okay, you are very brave girl. Okay,
Yes, sir. That's right.
done?
Yeah.
Nabila, done? Okay.
Yes,
So
sir.
okay. So let's move further. If I'm talking about this one, that is atoms. If we are having what? The third one, third postulate. What was the third postulate? In the third postulate, it was so that atoms of different elements have different mass, but in case of isobar, the different element can have same masses. For example, like we have nitrogen 14 and carbon 14. Okay. Like we have argon mass is 40 and calcium mass is 40. So these are the different elements, same mass. So what are isobars?
Different
Different
elements
elements.
having same mass.
Different elements having same mass. And what are isotopes? Same elements having different mass. Rima, turn on your camera. Let me check whether you are writing or not. Are you on your bed?
Sir, can you repeat?
Turn on your camera. Let me check whether you are writing or not.
Uh,
It's compulsory. We need to turn on the camera so that it will feel that. Done? Done?
Yes, sir.
Yes, sir.
Okay. So let's move further. Now we have talked about the atoms. According to modern atomic theory, atom is the smallest particles of an element which take part in the chemical reaction. We will not write that it is the smallest particle of matter. No. Atoms are the smallest particle, but electron protons are the further smallest particle. Okay, that are the subatomic particle of atom. So we'll write that atoms in modern theory, atoms is the smallest particle. As a whole, it is the smallest particle which take part in the chemical reactions that we have written in the previous class in the definition. That during the chemical reactions that take part in the chemical reaction. Okay, atom maintain its identity throughout the chemical reaction or a physical change. So atoms maintain its identity. What does this word means? That it maintains their identity. For example, hydrogen is a fuel. Hydrogen is a fuel and oxygen help in combustion. But water extinguish fire. So hydrogen when react with oxygen, it gives you water. It's a fuel. It help in combustion. Okay. But what does water do?
It puts out fire.
Hmm? It
It,
extinguish. Yes.
yes.
It extinguish fire. Okay. So you see that in water, hydrogen and oxygen are forgetting their identity. Neither the hydrogen is okay. Neither the hydrogen is showing its property of burning, and oxygen is not helping. Otherwise, when they are mixed together, H2O should be very combustible because one is fuel, other is oxygen. So they should combine together. They must be very combustible. But actually, water does not burn. So it does not mean they are losing their identity. When you do, okay, it does not mean when hydrogen is with oxygen, so it will lose its burning capacity. No, when you have water, when you pass electricity to it, when it gets separated, okay, then it gets separated. Hydrogen, when you pass electricity to it, okay, when you pass electricity to it, then it get converted into hydrogens and oxygen. It will gives you hydrogen and oxygen bags when you pass electricity to water using a battery, not this electricity that we use at home. Okay, so when we are passing electricity to it, okay, using hydrogen and oxygen, then it will get separated, and again hydrogen will act as a fuel, and this will help in combustion. Okay, so when they are in compound, they are not showing their property because it is a chemical reactions, and chemical reactions, the constant do not show their property. Okay, the constant do not show their property. But when they are separated out, then again hydrogen is start acting as a fuel, and oxygen start behaving, helping in combustion. Okay, so it does not mean that if we are just having hydrogen gas from we are just collecting hydrogen gas from atmosphere, that it will burn only. If we have separated out hydrogens from water, so because it was combined with water, we do not burn. So the hydrogen here we get is will not combustible. It does not mean what I'm saying here. I'm just repeating my statement that irrespective of anywhere from where you are collecting the hydrogen, if it is hydrogen gas, then it will show the same property. It does not mean that if you are collecting the hydrogen from the atmosphere, okay, there are several ways to collect the hydrogens. You can collect it from the hydrogen from the atmosphere because atmosphere have some percentage of hydrogen. Okay, you can collect the hydrogen gas when you pass the electricity to the water, and then it will start providing you the oxygen. So it does not mean that if the hydrogen is coming from the water, and water is not a fuel, so the hydrogen will not burn. No, hydrogen atom has its own identity. When it is hydrogen gas, then it starts showing its property. Okay, do not forget their identity. Okay, got it? Whether you are collecting the hydrogen from water, which is not combustible, but it will burn when you collect it from the water. Okay, or if you are collecting it from some atmosphere, there are so many ways to collect the hydrogens. So this is also okay. So it does not forget these identities. Okay, atoms are very small and hence can't be seen with a powerful microscope because they are very small in size. Atomic radius of the smallest hydrogen atom is this. This hydrogen is very smallest, and it is going to have 0.37 10 to the power minus 8 10 meter, or it is 0.037 nanometer. So atoms is very small in size that can't be seen even with the help of microscope. We
Can
use a
you
very
repeat it again?
yes, I'm saying here, Rima, that atoms are very small and they can't be seen even with the help of very powerful microscope. So if you are having a very powerful microscope, so you cannot see the atom from that one. Okay, you
Okay.
cannot see the atom from that one only. Okay, because it is very small in size. So hydrogen size is this one, that is 0.37. Okay, so note this one. Note this student, that atoms of the elements participate in the camping of an element. Note it down. Atoms of an elements take parts atoms of an element take part in the chemical reactions such that during the chemical reaction, atoms maintain their identity throughout the chemical or physical change. Atoms of
Sir, should I write from atoms of an element?
no, don't write it this one. We have already written this one in the definitions. Write it. Atoms of an elements take parts in a chemical reaction such that during chemical reaction, atoms maintain their identity throughout the chemical or physical change.
Okay.
Such that during the chemical reaction,
Such that during the chemical reactions, the atom maintain its identity. Note it down. The atoms maintain their identity.
Sir, I'm not able to see your screen.
You are not able to see my screen.
Yeah.
Okay. Are you able to see it now?
So still it's full dark.
Let me show you.
Yes, sir, now I can see.
Yeah.
Sir, should I write the second point also?
No second points, only the first point.
Yeah, I
Done?
wrote that. Yeah.
Alvina done? You, Nabila, Zaid, and Arya
Yes, sir. Yeah.
done. Okay. I have like yes, so done. Okay, so let's move to the next part here. So these are the names of some elements that we have written in the previous class also, but no need for this one. Okay. There are some elements, actually their names are written. How we are going to write the names of an element? Either it can be the first letter of the elements, like in iodine, it is I. Okay, like in nitrogen, it is N. Like in oxygen, it is O. Okay, like in like in okay. Otherwise, it can be the first two letters, like aluminium Al, argon Ar, and you need to note it that if first letter should be capital and the second letter should be small. Okay, while you are writing the symbol of an element, then the first letter should be capital and the other letter should be small. Okay,
Okay.
and okay, like we have in cobalt, we have C and small o. Okay, if we have C and capital O, it means that it is carbon and it is oxygen. Okay,
Okay.
okay. So if we have C, we need to write the names of cobalt. So cobalt should be C and small o. And there are some names. There are some names that you see here, that gold. Gold is not GO or capital G. Why it is AU? Because its Latin name is aurum. Okay. Okay. There are some elements that are named according with their, like the potassium is catrium. Catrium. Okay. So it is K. We have write their names according to their, some elements are named with their Latin names. Okay.
Okay.
Catrium. Like we have sodium. Where is sodium? Where is sodium? Sodium. Sodium is not written here. Okay. Sodium is Na. Na is sodium. And why it is not SO? Why it is Na? Because its original name, Latin name is natrium. Okay, like Ag, aurum, sorry, argentum. So there are some elements that are going to have their original name. Okay, and their names are written in the according to them. Okay, so that you will learn, you can easily copy it from NCERT. Okay, so let me show you this one, this portion in the NCERT. Okay, wait a minute. So wait a minute. So it's atoms and molecules. So here we have this NCERT and their names are written in here. So you have to copy these names here. Okay. This may be either which postulate of dynamic theory is result in the law of conservation of mass, which postulate of dynamic theory have definite proportions. So this are the questions. So initially their symbols were like this hydrogen. In ancient time, during that time, there is much not means not so much types of elements were discovered. There are few 15 to 12 elements were discovered during that time. So they were having symbol like this way. Okay, like hydrogen with one atom, like phosphorus, like copper. Okay, but later when we are discovering more and more, so this ancient methods were rejected, and we start writing their names in symbols. Okay. So like hydrogen is H and aluminium is Al, not A capital L. Okay, cobalt is CO, not C for capital O. So you need to write their IUPAC name according to this one. Okay, and this table you have to copy in your notebook, or you can memorize this one. Okay, some of the elements. Okay. Like we have some of the elements are written in their Latin language. Okay, is written Latin or German, Greek. Okay, their names like Latin names of iron is Fe. Fe is ferrum. Okay, like sodium is natrium. Okay, like potassium is kalium, not catrium. I have wrote there catrium. That is kalium. Okay, so by mistake I write kalium, catrium, but it is kalium. But sodium is natrium. Okay, so trium is here correct, but kalium is for potassium. Okay, so that's why potassium is not P, it is K. Okay, so like we have tin is SN, stenus. So according to them, we have written in. Okay, so let's move further. Right, and let's talk about the next one. So what is the atomic mass of an element? Let me discuss this one. That what is the atomic mass of an element? Okay. So if I talk about that, what is the atomic mass? Atomic mass is the mass of an element, that it tells us that how heavy an atom is. Okay. So for example, if you are just comparing the mass, means we are just comparing the mass of an element, that how an element can be, means how much it can be heavier. Okay. So for example, if you are just going to measure the mass, if you are just going to, you are having a very small scale, okay, that you use in your geometry box. Okay. And if I have given you this one and I ask you to measure the distance of from your home to, means for measuring the distance of 25 to 30 kilometers. Okay. Will you able to measure that one from your scale? No. Because
No.
that is very small in size, and it will take much time. So you will take the meter scale or the kilometer scale. You will take 1 or 2 kilometer scale, and then you will start measuring the distance. Okay. You will not measure it. Okay. So when we are just having, when we are just comparing quantity, when we are measuring something, then we take the measuring instrument relatable to that. For example, if you want to buy gold, okay, so will you be able to use that instrument example, you are just going to buy ornaments for yourself, or earrings or nose pin. So will you use those measuring scale or those weights that you buy vegetable, that you used to buy a vegetable from that one? No, that is 1 kg, 2 kg. Are you measuring 1 kg? This is the only pen size, nose pen. That's very small in size. Will you use this one? No.
No.
So you will use the weight which is comparable to that nose pen, and the size of the weight should be approximately same. Okay. So if I talked about that one, the size of atom is very small in size. So do you think that if you are just comparing the mass of an atom, so will you be able to compare it with 1 milligram weight or 2 milligram weight or 1 gram weight? Because no, 1 milligram weight is much higher, very large weight as compared to the mass of an atom. It is very small. It is just that if you are measuring the mass of an ant, the ant, okay, with the mass of 50 or 60,000 elephant. So thus you have a weight of 50 or 60 equivalent to the 50 or 60,000 elephant, and you are just measuring on the other side, you are having an ant only. It is very small in size. So you are just measuring a weight of ant with the weight which is having a mass of 50 or 62,000 elephants. Is it possible? No. Will you be able to make? Ant is very small, and even a one elephant is very big in size. So you cannot do this. Similarly, if we are just going to measure the mass of an atom, we cannot measure it in the grams. So we need to have some atoms which is comparatively equal in size of atom. And what is that? What is that weight which is equal to this approximately equal in size of an atom? So this can be considered as another atom. So we just considered, first of all, we know that hydrogen is the smallest element. So first we consider that hydrogen will be considered as the standard mass for comparing the mass of other atom. So we just consider that one hydrogen atom is a standard mass, and we will start comparing the mass of another atom with this one. For example, if you are having 5 hydrogen atoms kept here on one side, and you are having another atom, or we are having one, let's suppose we are having let's suppose we are having the 16 hydrogen atoms. Okay, 16 hydrogen atoms are going to have the mass of one oxygen atom. So we will say that the mass of one oxygen atom is equal to the 16 hydrogen atoms, and we will say that it is 16. Okay, because we have just considered hydrogen atom as a standard mass for comparing that. Okay, we are just considering, but due to some problems in hydrogens, okay, because hydrogen is not, we are not having the hydrogen atom like this, because hydrogen is very rarely available. Okay, and it is not combining with every other element, and due to its variable mass also, because hydrogen is going to have one mass and then 3 mass and 2 mass. So this is creating some problems. So we just rejected the mass hydrogen, and then we choose oxygen atom as a standard quantity, as a standard atom, and now we will compare that one. But due to some reason, oxygen is also rejected. Okay, let me show you here that atomic mass. Here is this. We need to learn this one, that the above table, do not memorize this one. However, it is convenient to use this number, whole numbers. Okay, this was an advantage that when we have shifted from hydrogen, and we have shifted from hydrogen to oxygen, then during that time, oxygen was helping us, because every other element is going to have the mass in whole. So whole number is the nearest whole number. Okay, while we are searching in various atomic units, then scientists initially took 1/16 the mass of naturally occurring oxygen atoms, and later it was also rejected. Then finally we have, in 1961, we have two isotopes of carbon. One is carbon 12 and carbon 14 that we have discussed. There are two types of carbon atom exist. One is carbon 12, another one is carbon Carbon
14.
14. So we have chosen the 12 one, the carbon which is going to have the mass 12. So we have chosen this carbon 12 as a standard mass for comparing. Okay, means we are having carbon, but when we have one carbon atoms, one carbon, because carbon is not the lightest element. So when we are having carbon, then it was having the mass of 12 hydrogen atoms, and it was having the mass of 12 hydrogen. So one carbon atom was having the mass of 12 hydrogen atoms. So what is the mass of one hydrogen atoms? So if we consider, then it will 12 hydrogen atom is going to have the mass of one carbon. So the mass of one hydrogen atom will be, one hydrogen atom mass will be, in terms of carbon mass, it will be 1 by 12th part of this one. 1 by 12. So one carbon atom is going to have the mass of 12 hydrogen atoms. So what is the mass of one hydrogen atom? It will be 1/12. 1/12, the mass of carbon 12 atom. Okay, got it?
Yes, sir.
So later, we have not chosen the whole as a whole carbon atom as a mass of as a standard mass. We just choose it 1/12 part. For example, here NCERT explain you that, for example, you have one watermelon and consider this watermelon as a carbon, and you divide it into the pieces of 12 pieces. 12 pieces. Then only one piece is considered to be a standard mass. Okay, so one piece, any 1/12 part of carbon atom is considered to be a standard mass. Now this piece, now not this as a whole, only one piece of this 12 parts. We have taken one piece and we just kept it here and we just start comparing. If we have this one piece will be equal to one mass, one hydrogen atoms. For example, if this such 24 piece, if this such 24 pieces is equal to the mass of magnesium atom, let's suppose 24 such pieces, 24 such pieces, okay, 24 such pieces is equals to the mass of one magnesium atom. One magnesium atom. So we will say that the mass of one magnesium atom is 24. If 14 such pieces of watermelon is equals to the mass of one nitrogen atom. So we'll say that the mass of nitrogen atom is 14. So if we learn that the mass of carbon is 12, mass of nitrogen is 14, okay, oxygen is 16. So what does it mean? It means that this nitrogen atom is 14 times heavier. 14 times heavier than the mass of 1/12 mass of carbon atom. 1/12 mass of carbon atom. Okay, one piece of carbon atom. That such 14 pieces will be equal to the mass of one nitrogen atom. So that we're going to discuss in the next class. Don't worry if you are having any doubt regarding to this topic. So we'll discuss this one in the next class. I hope you enjoyed the class. We're going to have the next class. In the next class, we will discuss this one. I hopefully that will start from the atomic mass. So please note it down when I actually ask you in the next class that which topic